Hello everyone and welcome back to the channel. So today I wanted us to dive into a really interesting aspect or a really interesting topic when it comes to Java programming. So in the previous video we talked about one-dimensional arrays and how we can use those one-dimensional arrays to store elements that are of the same type. So today we take it one step forward and we talk about two-dimensional arrays. So the use case of two-dimensional arrays is the same as the one-dimensional array but with more advantages. So what we're going to do in this first video is that we're going to go through two-dimensional arrays in a theoretical aspect, strictly theoretical. Then in a later video we're going to look at the code and how we work with two-dimensional arrays. So let's dive in. Now a two-dimensional array is simply an array that has other arrays within it. That's the simplest way we can define it. So a two-dimensional array stores data in a table-like structure. So typically a table would have rows and would have columns. So some key characteristics when it comes to the two-dimensional arrays is that it contains rows which represent the first dimension and then the columns represent the second dimension. The other thing that differs, the other thing that makes the one-dimensional array different from the two-dimensional array is when it comes to the indices. An index, we defined it as the numerical position of an element within the array. So in a one-dimensional array we typically would need just one index, but in a two-dimensional array we need two indices. So the two of them are going to be representing the row index and the column index. Then the other thing about the two-dimensional array is that it forms a rectangular grid structure. So exactly like a table and how a table would look. Also we can call it a matrix when it comes to the mathematical sense or the mathematical aspect of it. This is how we would expect the two-dimensional array to look. Now, to make this easier to understand, think about it this way. I want to give an example of a movie theater. I believe it's something that we are all familiar with. So, imagine you walk into a movie theater. When you look at your ticket, what do you see? In the ticket you see two pieces of information. The two pieces of information are going to be your row. So the row could be A, B, C, D, just as an example. And you would also find your seat number. So your seat number might be something like 1 or 2 or 3 or 4. Now, in the context of the movie theater, you actually need both of these to find your exact seat. That's the norm. You can't just say I am in row C. That's the whole row. And you just can't say that I am in seat number 5. So seat number 5 on which row exactly? So this is exactly how a two-dimensional array would work. So in our grid, the visual representation that we have here, we actually have a table. Just think of it like a table that has rows and columns, and that's how the 2D array will look when we create it. So what can we store? In our theater booking example, or in our theater booking system, which we are going to create later, each seat can have a status. For instance, you can have a seat that is empty. Empty means that seat is available for booking. You can have a seat that is booked, meaning someone has already bought that particular ticket. And you can have maybe a status of VIP. So VIP means special premium seats. In programming, the terms that we could use is, for instance, 0 to represent empty, 1 to represent booked, and something like 2 to represent VIP. So when it comes to understanding the concept of arrays, let me just go through both. A one-dimensional array means I'll give an example of lockers. Lockers may be within the gym. So you can have a single line of lockers and not just, a single line of lockers, which means just one index or one set of indices, if I may use that word. So to access the first locker, you would need index 0. To access the second locker, you would need index 1, and so on and so forth. For the two-dimensional array, think of our theater. So we have two indices. The first one to represent the rows, the second one to represent the column. And that is always how you're going to find your seat. I am in row A, seat number 2. I am in row C, seat number 5, just to give an example. So in the same aspect or context of the movie theater, imagine trying to store this theater data using just a regular one-dimensional array. It actually means you would need one array for row A, you would need another array for row B, you would need another array for row C, etc., etc. And that's actually so messy. That is where a two-dimensional array comes in handy. So it lets you keep everything organized in one structure. The example that we're going to be looking into in the next video is actually the movie theater, but there is a lot more that you can create with a two-dimensional array. So for instance, you can create a chess or checkers board. That one we would expect to have an 8 by 8 grid, 8 rows, 8 columns. You could create spreadsheets. That's another example. So it just has rows and columns, but we might not need to specify the number for those. You might create image pixels. That's another example. So each pixel has a row and a column position. You might also create maps in games. So terrain tiles in a grid might come in or might be created with the two-dimensional array. You might also create seating charts. So think of a classroom, think of a stadium, think of a plane, wherever. So remember this, but it's something that we're going to see practically when we actually write the code. So to access any position in a two-dimensional array, you always need the first index. And the question that we're going to be answering there is which row? That's the vertical position. You also need the second index. So the first index means the specific row. So row 0 has 0, 1, 2, 3, like that. When it comes to the second index, which column? So in the column, we are actually considering 0, the 4, and the 8. So just like finding your movie seat, you first find your row, then you find the seat number. So what I have in this is just basically what I have been discussing. So the differences between a one-dimensional array and a two-dimensional array. There is an example of how you would declare and initialize a two-dimensional array. There is also the initialization methods in this, and the memory representation. Actually, this is so important. How does Java store two-dimensional arrays? Now, the memory structure is an interesting one. So the main array holds references to 3 row arrays. So that means the first dimension here. The first dimension in a two-dimensional array always represents the rows. So each row then contains 4 integer elements. That's the other index right here. And that is why it's called an array of arrays. So for each row within our array, we expect to have 4 columns. So row number 1 will have 4 columns. Row number 2 will have 4 columns. Row number 3 will also have 4 columns. That's why we're actually using the term array of arrays. So it's the same basic thing that we have here. What else? The default values. It is actually true that, let me go back to this part here. If we were to create our array as it is in this particular illustration and leave it like that, the array is actually created, and those memory slots, those memory locations are there. If we do not add any elements to them, the memory locations are going to be filled up, and that is where this point of the default values comes in. So if it is an integer array, all those memory slots are going to be filled in with zeros. If it's an array of type double, we expect to get this. If it's an array of boolean, we expect all of them to be initialized to false. If it is an array of string or objects, we expect everything to be initialized to null. That's the expectation. All these we're actually going to look at when we get to that, when we get to the practical aspect of arrays. So this is also an example of how we can access elements. Since our two-dimensional arrays are expected to have two sets or two indices, it means that when accessing an element within a two-dimensional array, we need both the row index and the column index to access that particular element. Doesn't matter where in the array, but as long as you know the row index and the column index, you can actually access that element very easily. So thank you for watching or for going through the first video on two-dimensional array. Please be on the lookout for the next video, where we're going to now create the movie theater example and look at how an array or a 2D array works in action. But until next time, thank you.